For our next upgrade, we're going to go ahead and do some additional tuning to the power that's being provided to each of the stepper motors. This is another one I read about on the forums, tried to consolidate in all the information and figure out the best way to make these have enough power to work properly, but not have so much power that they are going to overheat. So that's sort of a balancing act. First step is to go ahead and take the information off the end of each stepper motor. Make sure you keep track of which one's which, and do some online research. I found that this specific motor, which is a silver, black, silver, sometimes that's why we're keeping track of the names, is a 0.95 amp motor. So we're going to use some information, some formulas found online to go ahead and tune this motor to only receive about 90% of that maximum power. You know, we don't need to drive it all the way to its full power, and hopefully this will quiet down a little bit and help it to run a little cooler. We're also going to do the same thing with our Z stepper motors, our Y and our X stepper motor, which are all similar. All right, the next step is one of my favorites. I've been into this box a few times. We're going to go ahead and remove all of the screws. And we use the exact same hex key set that we have that comes with the set here. I believe it's the second to smallest one. But again, there's 1, 2, 3, 4, 5, 6, 7 on the bottom side here. And then there's going to be 1, 2, 3, 4 on the back side that you need to remove in order to take this apart. So here we go. All right, with the screws removed, this is actually pretty easy. You just sort of slide the back off. Hey, there's one more left. Let's get that taken care of. Go ahead and take the back off. Just sort of lift up on this cable so this is out of the way. And then lay this flat. It gives you a little bit more room to work with. As you slide the power supply out, you see here's the power supply. It's mounted right set up for here, but upside down for us. And then you can just flip this over and set it to the side here. Obviously, one of the things you want to do is be very careful. It says very clearly there's high voltage operating in here. And once again, we're inside the control box. You can see some of the previous mods I've done. My emergency stop switch, which is really just a reboot that's sit on the front of the panel. The grounding mods and a few other little things I did here for the grounding enhancement. Next step is going to be to remove the actual Melzi board itself. So what I always do to start with is go ahead and remove the LCD cable, the LCD and control cable. Makes it easier to work with. If you haven't done this before, there is a little bit of hot glue right on the corner there that holds this in place. So you want to make sure to do that. Once that's released, you just want to go ahead and use the next size up Allen key, and you want to unscrew the 4 points of the board and remove it from the case carefully. Okay, now that we've got the Melzi board out of the actual enclosure here, you can kind of take a look and see how this is laid out. Basically what we have is each of these heat sinks up here is corresponding to one of the stepper motors, and underneath it is the actual stepper driver. So you can see right here is my X motor driver, Y, my two Z's, which actually share one adjustment knob here, or potentiometer, and then my extruder motor sort of by itself here, and it actually is called the E motor. And that's the one that I'm really after, but we're going to go ahead and do all of them. And as you can see up here, you know, we're on the 4.3 version of the Melzi board. This is with the Wanhao version 2 of the Duplicator i3. I've got the Monoprice Maker Select version 2 as well. But what we're actually after in here is these little potentiometers. So we're going to get nice and close here, and you can kind of see, we'll get a focus here. There we go. You can see that they've got a little tab on this side, and this is where we're going to be catching the probe. In fact, it's right up against the stepper heat sink, so we'll have to be real careful when we get our probe in there. And then we're going to be turning these until they reach a specific reference voltage. And the reference voltage is what tells the stepper motor how much current to draw. And I believe these things are tuned for the last version from the factory. And so we're actually pushing more current than this stepper driver needs to do its job, which is generating noise, and it's showing up as heat within the rest of the system. So it's time to do some math and figure out which one of these, or what each of these should be set to in order to provide the right amount of torque on the motor to do the job while not overdriving it for too much noise and too much heat. There's one other piece of information you need to know before you start doing your math here, and that is the value of the sense resistors. And so you'll notice that between the motor connector here and the actual chip itself, we have some resistors. And if I can get that to focus in. There we go. You can see that these are R100s. And it's always a pair, and it's always between the motor and the controller chip itself, or the driver. And so that's what we can count on. We'll be using that R100 value in our math. That's so much easier to see on those ones. And so they are all the same across the board, all R100s. Time for some math and research information here. Okay, the kind of motors we have here are stepper motors. So doing some research to determine the formula for this VREF that we're after. Now what I did was I read up on what kind of motors I have. So if you recall, my E, Y, and X are these model number motors. The Z is a different model, but not far off. And then we've got our formula directly from the forums and the wiki page showing VREF is equal to current in amps times 8 times the sense resistor. So we've got a lot of our math done for us. What I discovered along the way is that this is not an arbitrary model number. This is a 42 millimeter hybrid stepper that's a 34 millimeter length motor. Okay. 0.95 is the maximum amp draw. Now the rest, still don't know. I'm sure it has more information, but that really tells us everything we need to do our math. Now looking up the information grids on this thing, and there's a couple places to find it, I verified both of these numbers. So this particular motor, my EY and X, is a 0.95 amp motor. Thus our current is set to 0.95 in our formula. The other one, again, I confirmed, is a 1.2 amp motor. So these numbers actually make a lot of sense. So if we do the math here, 0.95 times 8, which is that multiplier number, times 0.1, if you remember our sense resistor pair was a R100 giving us a 0.1 number here. Do that math together, and the answer to this is 0.76. All right. Now we want to do 90% of that because we're not going to drive this thing all the way to its full current. We don't need that much energy to drive the filament through here. And it also, ends up being just too much for the job. So what we're going to do is we're going to say, set our formula here, 0.76 times 0.90, and that answer is 0.684. So if we take 90% of this value, we're actually providing 0.81 amps. And so this value of 0.684 will tell the stepper motor, go ahead and draw 0.81 amps of power, which is 90% of our 0.95. So that's the first one. That's pretty straightforward. If we then take that same formula and apply it to the 1.2 amps, let's go ahead and put that in here and say equals 1.2 times, again, our 8, times our sense resistors, our 0.1. That is going to come out to be 0.96. All right. So that would be, if we gave it a 0.96 reference voltage, that would drive the full 1.2 amps of draw. It would tell the motor to go ahead and take all that. But we don't want to drive that. So again, we're going to do a 90%. So equals 0.96 times 0.90. And that's going to come out to a VREF of 0.864. That's kind of how to do that math. So that is really how you figure out what you're going to be tuning the VREF to, or the reference voltage, and that's going to tell your stepper motors how much current to draw to do the job it needs to do without expending a whole bunch of energy as heat, causing overheating and causing in general problems. So to set up our negative lead here so that we get the probe, what I'm going to do is I'm going to unscrew the ground wire from the main power feed. So you can see under here, this one's the power one. So that's where we want to get our reference ground. You can get it in a lot of other places. This has the added benefit of making sure that you're truly disconnected from the board at this point. So we're going to pop that out. We're going to take our ground and pop that in there. And I'm just going to give it a little twist so that it doesn't go jumping out in the middle of my testing. So now we've got a nice tight connection for our ground power. All right, we want to power this board off of a micro USB connection. What you'll notice here on the board is that we actually have a jumper here that says we can use VREG, which is the voltage coming off of the actual power supply itself, or we can use USB power. So we're going to remove this jumper, and we're going to switch it over to the USB pins, which from my view, you see I've got the board upside down here, is these top two, and they are labeled USB pretty clearly right there. So now we're going to go ahead and I'm going to unplug this from this side first, and I'm going to plug the USB connection in here, or the micro USB, actually, the mini USB. It's weird to go back to mini USB after all these years of micro USB, and we're going to plug in the board. So we got everything set up now. We are grounded on one side, and just a piece of information, you can't actually get to the right side tab, which is I guess the left side on the bottom here, without touching the actual heatsink. Now the good news is the heatsink is not grounded to the board, so we shouldn't be causing any problems. But you'll notice I touch here, and I'm getting an 817 value, okay? That's for the X motor. 777 on the Y motor. 789 for the Z motors. Oop, I'm blocking your view here. And a 785 for the actual extruder motor here, which is the one I was really after. So you can see that these are a little high in comparison to that value we calculated of 684. So I'm going to go ahead and taking the screwdriver here, I'm going to turn this down just a little bit. I'd love to be able to do them at the same time, but I don't think I've got that fine a touch. So I'm going to turn this down just a little bit. We're not driving anything yet. Okay, so we turned it just the littlest bit here, and let's see where we're at. I'll be a little more careful with that touch. 748, so we're going in the right direction. And remember, for my X motor, I'm looking for a 684. A little bit more. 641, so we overshot it just a little bit. So we're going to turn this back up just a notch. And this is a clockwise up, counterclockwise down, so at least that's making sense. 640. Why not shoot for gold? Guess I didn't move it. So tweaked back and forth, saved you the punishment of watching that. But now we can look here, and that's 690. Again, our target was a 684. We got 690. Our range that we want to be is 90 to 95%, so I'm going to call that pretty dang good. So I'm going to work down the line and tune each motor I'm going to skip the Z motors because I really don't have the information to calculate that just yet. I thought on this a little while about the whole Z motor thing, and what we're really generating here is a reference voltage. We're not supplying any sort of power. This is just sending out a signal to the motor to tell it how much actual current to draw. Now, since this signal is going to be sent to both motors, we can actually set for the calculation of a 1.2 amp motor. So you can see, if we're going to go back to each one, if I go to the X motor, 689, target was 684, good. Y motor, 689 for 684. The Z motors, which I came up with a 0.864 as my target, 863, I'll take that. And then finally for the extruder motor, 0.689, again we were shooting for a 0.684. So well within all of our tolerances here. It's time to go ahead and put this thing back together and test out and make sure all the motors are operating properly. So I'm going to disconnect the USB power. Once that's off, I'll go ahead and remove my negative lead here, plug the power back in, and before assembling everything, I'm going to go ahead and power the unit back to the actual power supply. So that will require moving the jumper back from USB to the VREG resistor, or sorry, jumper that tells it to get power from the actual power supply. Back up and running. We've got the power supply plugged back in. We're still hanging out here in sort of the helping hands configuration I was in before, but we've provided power to our power supply again. We're being very careful not to touch this. Again, I don't recommend doing it this way, but before I reassemble everything, I'm going to do a quick sanity check. So just the first check I'm going to do is I'm going to rehome all the motors and see what the difference is as far as volume level. It's not a huge test, but at least it gives us some feedback. And it also tells us if the motors are working. A little bit quieter than it was last time, or before I tuned these. Not a huge amount, but really what I was looking to do was to cool down the extruder motor. It was getting pretty hot to the touch when I was running long print jobs. Could have been a symptom of being in the enclosure or something else. I'm going to go ahead and do a quick leveling, make sure everything's nice and level, and then I'll fire off my D3 cooler test print, and we'll just see a couple layers and listen for it, and let me see if I can hear if it's changed significantly now. Okay, after a spectacularly bad jam that I created by doing dumb things, we're back and ready to demonstrate an actual print with the tuned stepper motor drivers. I think it is quieter, and again my goal was not necessarily to be quiet but to be cool. So let's pull a temperature reading off of the stepper motor. Looks like I got 27.6 C off of this one. You can see it actually was probably more around 30 degrees C, which 81F, not too bad. About 25 on the X motor. and somewhere to the tune of 25 on the Y motor. The Z's are going to be a little harder to shoot, especially while it's working, but we'll go ahead and give those bodies a little scan. Still around the 23, and the far one's reading 24. So not too bad at all. I'll go ahead and give this a few minutes to run and see what it's reading at after a few minutes. Okay, we're 10 minutes into the print now, and it's still printing flawlessly at 130%, which is good. And I am still reading 30C on the E motor. About 29 on my X. I didn't take the Y's last time, or the Y motor last time. 25 on it. And about 25 on the Z's. I'm going to say this is successful, and we'll say that we did some better tuning. We're getting a lot less heat. When I originally clocked my extruder motor, like I said, it was so hot you couldn't touch it. So I'm assuming we're talking something, right around 115 to 120 F. And yeah, it was uncomfortable to the touch. So, success!